Hello, is it working? Fine. Hello. Hello everyone, I am Shruti. I am engineering director at American Express. About the work experience, I've got a vast experience in data. And on my personal front, I am a mother of a toddler who has just returned from the maternity leave for like some months back. And it's a wonderful journey so far with a toddler at home and data at work. So great journey so far. So this is about my bio. I would like my co-speaker Yoshita to introduce herself.
Yeah, hi everyone. This is Yoshita, and I'm working with American Express as Senior Engineer 1. And I have vast experience in data analytics, cloud computing, data warehousing. So I'm a leader and innovator in my field. Plus, along with my work, I love to travel with my family. Thank you, Shruti.
Sure. So this is the landscape of American Express where we are working. It gives you some facts and details about it. Now, our topic for today is tuning in tandem of financial data pipelines. Just this is the most interesting aspect of any data pipeline when it comes to tuning because it's all associated with the performance, efficiency, and all those factors. So some of the objectives for today's session, what are data pipelines? We'll give some example of data pipelines and design principles associated with it. Some parameters of data pipelines which are very critical, and then tuning. The most interesting part, we'll come to it. And last, the takeaways from the session. Now, what is data pipeline? I'll give some background of it. In the era of Gen AI, cloud computing, the volume of data, the variety of data, structured, unstructured, file, images, videos, the inflow of data is very fast, the variety of data is very fast. And now the need is we need to process that data at a very fast speed, acquire, enrich, and provision it to the downstreams at a very fast rate in order to have an edge in the market. Now when it comes to data pipeline, it is the set of automated steps which can help us to achieve this. We can ingest the raw data, process it and provision it at a very fast speed and in an automated manner. Now an example of financial data pipelines. Now when it comes to the finance data, what is it about is the transactions, the balances data which we have, which we receive from various system of records like consumer account receivable is there, corporate account receivable, loans data, deposits data, loyalty. All those system of records act as our upstream system or the source system. We ingest that data into our data pipelines which has various integration mechanisms like table to table integration is there, file to table, file to file. These type of various integration mechanisms we have with our data pipelines where we ingest the data, acquire it, enrich, aggregate it, and create a summarized view of the counting events. When I talk about accounting events, it is associated with various events like credit balance, debit balance, cycle cut events, all these events related to the financial data. And then we provision it to the downstream systems. Now for the financial data, the various downstream systems which we can have is accounting system, which is associated with the general ledger or your sub-ledger systems. The next is the regulatory reporting. In India, we have RBI, which is associated with regulatory reporting. In US, we have Fed Department. So these are some of the downstreams. Next is the management reporting, where we provide the various dashboards which can be presented to the very senior leadership and they can know about the landscape where our organization is going towards. Next, I would like to talk about some of the design principles which can make your data pipeline as the more robust one and cost effective also. So first, it comes to my first design principle I like to talk about is the one framework or the standard framework. So whenever we have multiple use cases like loans data is there, deposits data is there, lot of system of records are there. And we should have some 80% of the boilerplate code available And on top of that, we can have our configurations. Configurations associated with the source, the sink, and the transformations like map transformation, reduce transformation. These are all technical transformations which we can have. But the idea is that we should have one framework. The standard framework should be available, and on top of it, we can have all those configurations. The purpose it will solve is that the time to market would be less. We can deliver more use cases at a faster rate. We can ingest data at a faster rate, process, provision. The speed would be high. Then the reusability factor, which goes along with the cost. It would be cost effective if we have one framework. These are some of the design principles, and other two important ones associated with it. First is the data governance. When we talk about data governance, it is the entire lineage of the data, from where my data has started, what all transformations it went through, and where we are provisioning it. The entire lineage of the data comes under the data governance. We have various tools for it, Collabra, Menta. There are so many tools associated which we can use for it. Now next is the analytics part, reporting part. On top of it, supposingly we need to see where are the spikes are. Supposingly the balance goes off the record, and then we need to see and check why it has gone like that. So we can do analytics on top of this data and find out these anomalies out of it. Now, some of the parameters which are associated with the data pipelines. One is the speed, which is the latency. Do we want our data in a real time, or we can have a batch processing also? We have a Lambda architecture through which we can have both also when we have to process our data to various machine learning models. Then it is about control. When I say control, financial data is provisioned to regulatory department, where we need to have certain minimum required controls in place. The executions should not be duplicated. We should not miss any execution. Reason is that it has a huge impact on the accounting system, our general ledger and the sub-ledger. So although these are very small minimum required controls, but the impact of it to the downstream is very high. So we need to have these minimum required controls in place. Now next, I would like to talk about the security. These are two different aspects. As we have seen, the financial data is the most critical data, because the losses which can be incurred out of any data loss or data leak would be very, very high. We have seen in past that there are very big financial institutions who suffered major financial losses because of very small checks were not there, like code review did not happen, or the vulnerability scan was not happened. Because of that, they had to incur very huge losses. Then next comes the cost, which we can balance using the one framework which we talked about. Resiliency would be covered in detail by Yoshita, and very important factor is the scalability, that we should be able to process millions of transactions in a matter of time. It shouldn't take a long time. So the scalability is a very important factor. And now we'll see how we can tune these parameters, what is the importance of each parameter, so that we can build efficient data pipelines. Now when it comes to scalability, what comes to our mind is the distributed processing. We should be able to process our data in a distributed manner first at the application level. Now at application level, we have various execution engines which works in memory processing, which is fast, and also it works in the distributed manner. Like Flink is there, Spark as an execution engine is there. It depends on the use case which execution engine we want, so that it can do the processing in distributed manner. Now next come at the database level. We have processed our data through an application. Now we need to sync it to a database. If we'll have a very fast processing at application level but not at the database level, it can create a back pressure. So in that case, we need to have a distributed processing at database level also. We have various databases like single store is there, which is row store and columnar star both. So we can have distributed data processing. And the another factor is the moving to cloud. That is that depends on the use case, whether you want to have an on-prem solution or move to the cloud with the benefits attached to it. That also we'll talk about. Now when it comes to the tuning, we are able to process the data at a very fast speed. We are able to handle the large volume of data, but at what cost? So we need to have an optimum cost also attached to it. For that, we need to do certain steps, like data deduplication is one of the steps. Then along with it, we need to monitor the resource utilization. If we are using Flink as an execution engine at the application level, we have a Flink dashboard which tells us the resource utilization, which we can handle from there. And about the cloud, if I say, we have an auto scaling features that also we can use to make it cost effective. Next, I will talk about resiliency, which Yashda will cover.
Okay. So for any data pipeline, resiliency is very must. Resiliency is something wherein your pipeline should keep on working in case of any failures, any natural calamity occurs, where your data would be stored, but still your system should keep on working smoothly. So the first thing that we try to do at every step while tuning a data pipeline is the event journey, wherein dashboard, wherein you can replay. If there is any failure, you can replay your DAGs. DAGs is something wherein you can start your jobs again from the point of failure. Secondly, there should always be a stress test and resiliency drills that keep on happening. Then a data governance should be in place, that is data lineage. Data lineage means from source to target, how your data is flowing, what are the checks that have been kept. So that is documented properly. Third is anomaly detection. Anomaly detection is something unusual patterns which you can detect through the help of machine learning. So any fraud detection. So that keeps your system resilient. And third, last but not the least, is the disaster recovery, which is a must, which is kind of what you, at the time of disaster, how you can recover your system from the point of failure. So, Shruti,
It's a little hard.
sorry.
This one.
Okay, sorry. Yeah. So along with the resiliency, we need to keep some control checks. So the control checks are like balance and control check. That is the main thing in the data pipeline, wherein we keep on checking if we are moving data from one system to another system, how the data is moving, whether the count and the balance is same or not. Then we keep on keeping the auditing and logging in place. And the last, for all of these, if this is not in place, a notification and alarm should go to the concerned team, concerned people who can just recover the pipeline. Then we go to financial data security. So data security in financial data is the most important thing. And we have two kinds of financial data security, that is application level and database level. So application level includes code review and documentation. So all it should be documented, codes should be reviewed, and password initially we are stored in vaults. So that is the most important thing that we do. And continuous vulnerability scan and fixes needs to be done as part of the application level security. This helps in keeping your data secure and compliant to the system. In the database level, we have role-based service accounts checks, that is role-based access. A certain person can see 10 records, another person can see 50 records. So that is how at the financial data pipeline we keep on tuning and keep the system secure. The third is the encryption. Encryption is the most important thing. In financial data pipelines, we have a lot of personal information that is stored. So the data needs to be encrypted. So the data at rest and data that is moving, both needs to be encrypted. And the last is the ACL, that is the file level controls that needs to be in place. So now, once we have tuned our data pipeline, so these are the main headers or the bullet points that makes your data pipelines efficient. So any efficient data pipelines has a high scalability, then it has high access control management, it has low data quality concerns, low complex data lineage, and last is low vulnerabilities in the system. So now hope you have enjoyed the session, and Shruti will be taking away the key takeaways.
Thank you,
You.
Yashita. Okay. I would like to summarize it by giving some key takeaways so that you can have it from the session. When it comes to the scalability of data, we should always consider what is the data growth we are expecting. At this point of time, supposingly we have some million transactions, but we need to take into account what is the data growth we are expecting. Next comes to the cost part. There we should always take into consideration whether on-prem versus cloud would be a better solution. Should we build the solution or buy it? Or how much is the time to market we are expecting for it? When it comes to speed, we should have optimal controls in place and there should be effective testing. We should replicate the production like scenarios to our lower environments and do the testing over there. And should always encrypt the data while bringing the data from production to the lower environments. Next is the resiliency, an important factor. We should always have a DR cluster, disaster recovery cluster in place, and our system should be fault tolerant. For controls, there are minimum required controls which has to be there in the system. And when it comes to security, we should always classify the data, whether it is PII, internal, restricted, and then apply the security on top of it based on the requirement. Hope you guys enjoyed this session and would have some key takeaways from this. Thank you.
Thank you. Thanks, everyone.
Thank you.
Thank you so much, Shruti and Yoshita. It was a lovely session. Can I request the session chair to present a token of appreciation to our speakers? All right. Moving ahead, we have a keynote session, a quick insight into network function virtualization in cloud. And this is the closing session for us. We have Malar from IBM India Private Limited as a senior software engineer. She will take us into the world of network function, virtualization, and its role in revolutionizing cloud infrastructure. May I have Malar on stage, please?
I can talk. Sir, okay, sir. Oh, okay, sir. It's working.
One.
Please join hand and welcome our keynote speaker, Malar from
Yeah, hi,
IBM.
everyone.